Hello guys, welcome back to Math Zone African Motives. We are still on our revisions and preparing for our examinations. This is our O-level mathematics, working with the kinematics, and that's the introduction that we are going to work on, which is on the travel graphs. So it is very, very important that you do understand all the basics, which is going to help us in answering the typical exam questions. If you check along the channel, you are going to see that we have videos already, which is covering question papers, exam questions, all right? So what I'm going to do is to give you a basic introduction so that you'll be able to answer these typical questions by just interpreting the travel graphs. You need the interpretation first. So we do understand that when we are working with kinematics, this is simply the study of objects moving in a straight line, all right? So here we are simply talking about the study, all right? That is the study of what? Of objects, all right? The study of objects moving in a straight line, in a straight line, okay? And that's actually when you're considering a straight line, that's a rectilinear motion. So in actual sense, you're talking about the rectilinear motion, all right? This is study of moving objects, moving objects, all right? The objects that are moving in a what? In a straight line. That is the rectilinear motion. And this happens with uniform acceleration. So that's with what? Uniform acceleration. With uniform acceleration. So this is the major case that you have on the kinematics. So we are going to consider under this kinematics, the travel graphs, which according to your syllabus, you must understand the speed time graph or the velocity time graph. So we've got a speed or what? Velocity time graph, all right? That we are going to consider. And also, you must understand the distance or what? Displacement. Distance or what? The displacement. The displacement time graph. So this is the major concept actually that you are going to need in the calculations later on. But like I said, this is an introduction where I'm just going to give you the basics of what you need in your syllabus. So the first part is just the interpretation of these travel graphs. We need to interpret both, all right, the speed time graph and the velocity time graph from what we are used to generally from our algebraic graphs, all right? Let us say we are given, in this case, a basic graph, which is being taken from our algebraic graphs. Remember, from our algebraic graphs, this is your x and this is your y like this. Let's say we have got a linear function or a linear graph, which is what? A straight line. We want to interpret this under what? Our travel graphs. We want to interpret what is happening. Remember, there are two of them. We can have the speed, you can have what? The displacement time graphs. All right, so using the displacement time graph, all right, that is ST. So I'm going to consider S for what? Displacement, then T for what? For the time. All right, so this is what we are going to have for the first one. All right, this is just an interpretation. Let's consider this as the first one. All right, so like I said, I'm going to have two things to consider here. The displacement time graph, all right, the displacement time graph, meaning to say from this interpretation, we are going to have it under the what? The displacement time graph as well. We are going to interpret the same type of this linear graph, which is considered from our straight line graphs, right? We are going to do the same thing for our velocity time graph. What exactly is what happening? So we do understand from our algebraic graph, given x and y, this is our origin. And in this case, as we have got a straight line, we understand the concept of the gradient. The concept of the gradient. We do understand that on a straight line, if we are to consider the gradient, it is the same. We understand the concept of what? The gradient, which is constant, all right? Which is what? Constant, the same throughout. The gradient here is the same throughout on a straight line. If you are given 2 points, this point and this point, the gradient that you're going to calculate using these 2 points is the same even if you are to use other 2 points on the same straight line. The gradient is the same. Any pair that you're going to consider of points, you're going to obtain what? The same gradient, which is what? The constant gradient throughout. So that is the major case. And in our case, for all lines which are like this, they are referred to have what? Positive gradient. The gradient is what? Is positive. Whereas if the line is facing down like this, it has got what? A negative gradient where the values of x are increasing, the y values are decreasing. That's what we have got, a negative gradient. So in our case, this gradient that I'm talking about has got a presentation, what it represents under the displacement time graph. That gradient represents the velocity. So that gradient that we are talking about represents what? Represents velocity. It equals to the what? To the velocity, which is normally measured in what? Meters per second. So I'm saying that if we are given a displacement time graph, this is going to be our displacement, this is going to be our time, and we have got what? An increasing functions are this straight line that we are given here. So for this straight line, where the values of t are increasing and s is also increasing, all right, this is what we have, which is a straight line being formed there represents the velocity function. So we have got a representation of the velocity. Yes, at each point, if you're going to consider each point, what is simply happening is that at each and every point, it corresponds the time to the what? To the displacement. So meaning to say, at this point, if you are to use displacement over time, it is the same thing that you're going to have. That displacement over time gives us what? The velocity. The velocity is simply the rate of change, all right? The velocity, we are referring to the rate of change of what? The rate of change of what? Displacement. So that is the concept that I'm referring to here. So it is the same throughout. And that is the gradient, which we are saying is what? Is a constant. The gradient from a normal algebraic graph, which is what? A straight line like that. We do understand that gradient is the same. But that gradient represents what? Velocity. So if it represents velocity and we say it is constant, it simply means this object, right? So under kinematics, we said we are referring instead of what? Moving object. Anything is referred to as what? As an object. A car, a train, a bicycle, any part is referred to as a what? As an object. So in this case, where the velocity is constant as we referred to our gradient, we are simply saying the object is moving with a constant velocity. That's the object. The object, in this case, this is the interpretation of what we are seeing here. The object is moving, all right? So the object is moving with constant with constant what? Velocity. Since velocity represents gradient, and this is what we see is what? Constant throughout. All right. And we talked about another thing, which is the gradient being positive for all these lines facing up like this. They have what? A positive gradient. So meaning to say the velocity is what? The velocity is positive. In this case, the velocity is what? Positive. So that's positive in short. What is the meaning? Velocity, guys, okay, in simpler terms, wherever we've got velocity, let's just put this way, speed in our mathematics, all right? For those who are doing science, we know that it can be actually different things that you are referring. Velocity, you take it from displacement, whereas speed, you take it from distance, all right? But in our case, let's just consider the way that you understand as speed, all right? So if we are saying the speed is positive, what actually is happening? The speed. The speed is the one that you see here. Let's say you have got your car, the speedometer. If you check on the car, we've got 0 and so on and so on, depending. Some other cars, they end up to 240 kilometers per hour, something like that. So if we have talked about the increase, it is increasing from like that. So positive values simply means you are having an increase, meaning to say the car is actually moving forward. The object is moving forward. So when it is moving down, you'll be now considering a reverse. When you are reversing, it is now decreasing. We've got a decrease, which is going to the negative. But as you are going to the positive values, it means what you are having there in terms of the object is moving forward, not reversing. So that's when the velocity is positive, it simply tells us that the object is what? Moving forward. That's the object. The object is what? Moving forward. Object is moving forward, not reversing. There is no reversing in this case, all right? Not reversing. All right, so this is the consideration of a displacement time graph from this interpretation of from our algebraic function or the algebraic graph considering a straight line. This can also happen on the velocity time graph. We want to interpret the same thing, but this is velocity and what time for this increasing graph that we are given, where the t is increasing and the velocity is increasing as we have got there. This time, when we are to consider the velocity time graph, the gradient has changed. The gradient has changed. It's no longer representing velocity, but whenever we deal with the velocity time graph, it's all about the acceleration. All right. So that is the acceleration at any point that you're going to calculate is going to be the same as we talked about what gradient being the same, being constant. So that is your acceleration. So we are saying this is what? Our acceleration. All right. So in the case of acceleration, it can be positive acceleration. It can be a negative acceleration. Where you obtain a negative acceleration, it means that there is a deceleration or a retardation that is occurring at that moment. And acceleration is simply taken from velocity over time. So that simply means what? The rate of change. The rate of change of what? Velocity. The rate of change of what? Velocity. That is the case. So from this case, the line that is being drawn, we are from what? Velocity and time. But it represents the major thing, acceleration at any point, which is the gradient. And that is what? That is constant. Remember, I said gradient is what? Constant. And that gradient represents what? Acceleration. So the object, in actual sense, The object is moving what? The object is moving with constant what? Gradient, constant what? Acceleration. That is the case of a velocity time graph. It will be your acceleration in that case. So thus, when the acceleration, which is our gradient, when the gradient is positive, it means our acceleration is what? Our acceleration, I'm just going to write in short, our acceleration is positive. Here, we are talking about velocity. From what? From the displacement time graph. The acceleration, I mean, the gradient was representing velocity. So we're saying the velocity is positive. Here, acceleration is positive. What is the meaning when the acceleration is positive? It simply tells us that the object is gaining speed. It is gaining velocity, not reducing it. It's not about the object being moving forward. It's about gaining velocity. So the object Thus, the object in this case, the object is what is gaining. The object is gaining velocity or speed. It is gaining velocity or what? Or speed. All right. That is the concept of what we are having from this interpretation of a constant gradient and being what? Being positive. So meaning to say, if it was a negative from what we are seeing here, a negative gradient, it was going to be like this facing down. That's what a negative gradient, where the values of x are increasing, the y values will be what? Will be reducing. That's another interpretation that we can actually have. So I'm not going to have much. I'm just going to have this in short. Then you can use this information, guys, to attempt questions using that idea of what is happening from here. All right, so let's consider from our normal algebraic graph, this is our x and this is our y like this. All these lines like this, guys, they have got what? A negative gradient. So as we are to consider here, the gradient is what? The gradient is negative. Remember, when I talk about gradient, guys, there is the change in y over the change in x. All right, where we consider y2 minus y1 over x2 minus x1. So when you calculate that gradient, you are going to obtain a negative value for all lines, any line which is facing like this. It gives you a negative gradient, any. So if you calculate that, obtain a positive, it means your calculation is wrong. But these lines, the first one here that are facing this side, they have positive, all of them, not some, but all of them, they've got what? Positive gradient. All right, so in our case, what just changed here? This is the same gradient is for velocity from ST, everything that you had here is the same, only that we are now considering this being a negative, this being a negative. And when it is negative, it means for acceleration, it is a deceleration that is okay. That is the only thing that is happening, guys. So interpreting, let us interpret this for the displacement time graph. So meaning to say for our displacement time graph, that was gonna, remember, this is all about what? All about the velocity. The gradient concept represents what? Represents velocity, like I said before. All right, then we gonna also have the same thing on the velocity time graph here. All right, so on the velocity time graph, velocity time, the line that we just drawn, it's gonna represent gradient at any point, which the gradient is what? Is an acceleration, and that's a negative acceleration from here. So this one, it's a negative velocity. This one, it's a negative acceleration. Negative acceleration simply means that is a deceleration taking place. All right. So since we are dealing with a straight line, we haven't changed anything from the concept that we had from the displacement time graph. It is going to be the same. Gradient is what? Velocity. The object is moving with a constant velocity, just like before, but only the velocity is what? is negative. That's the point that is going to change here. The velocity is what? The velocity is what? Is negative. All right, since these lines have got negative gradient, so meaning to say your velocity is going to be what? Is going to be negative. And when the velocity is negative, what does it mean? It means that the object is reversing. So thus, the object is what? Is reversing. The object is reversing for a negative what? For a negative velocity. Whereas considering the velocity time graph, the gradient represents acceleration. Remember, for a velocity time graph, gradient equals acceleration. Only that the acceleration that we have, it's a negative. So when our acceleration is what? Is negative in this case, when our acceleration is negative, like what we have, it simply means that's a deceleration. So you're talking about what? A constant, since it is constant, all right? So we're talking about a constant what? Deceleration or retardation. So deceleration, that is what? That is also referred to as a retardation, meaning to say the velocity is decreasing in actual sense. So thus, the velocity is what? Is decreasing. The velocity of the object, the velocity of the object is what? Is decreasing. So that is the concept of what? A negative value in acceleration. It simply means that the velocity of the object is decreasing. This is a concept when you are driving a car, then you are towards a robot, you're going to reduce the speed, all right, decrease the speed, or maybe you're actually braking the car until it stops, until it comes to rest. That's until the velocity is that from a certain value of what? Velocity, from a certain value until you come to rest, it is simply showing us a decrease. But since it is a straight line, that decrease, it is what? It is constant. That is the same thing as this velocity. The velocity here being negative, when you are talking about what? The displacement time graph, it is also constant, just like what we had before. So that is the condition. So here, for a velocity time graph, like I was saying, examples can be a condition when braking, when you're considering braking of what? Braking of a vehicle or a bicycle, all right? You are moving towards a stop sign, then you are reducing the speed. That decrease in speed is showing what? A constant deceleration when it is forming what? When it is forming a straight line like this, all right? So that is another interpretation that we can have when there is a negative gradient. Then there are some conditions that the gradient, when it is calculated, it gives us a zero. This condition is described with a horizontal line, all right? When you are given from your algebraic graphs, you have got a straight line like this, a horizontal line. For all horizontal lines, we do understand that the gradient is zero, because at that point of a horizontal line, what happens is that the x values changes, right? The x value changes, but the y value does not change. So x is going to change to another value, but the y value remains at the same point. So if you are to consider your points, they were going to be x1, y1, and another point being x2, y1, since y is not changing. It is horizontal, so that's y is equal to a certain value. If it is 5, it is the same throughout. So the y value is the same. So if you're going to calculate your gradient using the change in y over the change in x, you're going to subtract the y values, which are the same, y1 minus y1 over x2 minus what? X1. So since these two are the same, it is going to give us what? A zero. All right. Remember, 0 over any number is equal to a 0. So that's therefore the gradient is equal to 0. So that concept of the gradient, remember, is the one that we are interpreting. So in this case, our gradient is equal to 0 for all what? Horizontal lines, for all horizontal lines. All right, so this one, please take it into consideration. So when we are to interpret this back to our travel graphs, remember the first one being our displacement time graph, we want to interpret this now. So what exactly is happening? So this is going to be the case. Remember, it is what? A straight line like this. And we said the part that is a gradient here for a displacement time graph, it is not the gradient in sense, but it represents the velocity. So if we said the gradient is equal to 0, it means our velocity is what? Equal to 0 for a displacement time graph. That is the major case that you must consider since we are referring to what? The gradient as the velocity. So the velocity is what? Is 0 in that case. Meaning to say, when the velocity is 0, remember velocity, we're talking about what? Speed. When you're saying the speed is 0 meters per second, speed is taken from what? Distance over time. So meaning to say, to obtain a 0, there is no movement at all. The distance there, there is no movement. We are still at a single point in terms of the distance. So that's the object is stationary, not moving. This is the representation of what? A velocity being 0. That is what? The object, that is the object is not moving. The object is not moving. This is the concept. It is not moving. It is what? Stationary. When it is not moving, it means it is simply what? Stationary. There's no movement. So when you are given a condition that this is stationary, know that they are simply referring to what? Velocity being equal to 0 for a displacement time graph. This is the idea of what is happening here. So if it was a velocity time graph now, what is our interpretation from what we are given here? All right, so this is our time, this is our velocity. So remember the concept, we've got what? A horizontal line, where for a velocity time graph, gradient represents what? Remember, gradient represents acceleration. So when the gradient is equal to 0, it simply means our acceleration is equal to what? Is equal to 0. This is the concept of what? Your acceleration. It is equal to 0. When acceleration is equal to 0, what does it mean? Remember, acceleration is the rate of change of what? Velocity. Velocity over time. The velocity there to be at 0, it means the velocity is the same when the time is changing. The velocity is the same. The velocity is constant. It's not about the object not moving here for a velocity time graph. No. It's about the velocity not changing. That's the velocity being constant. So having an acceleration being equal to 0, it simply means that, okay, that is the object, in this case, the object is what? Is moving. The object is moving at a constant what? Velocity. At a constant velocity, or at a constant what? At a constant speed. It is neither increasing nor decreasing. It is just constant, the same. Velocity is the same. At this point, the time, velocity, at this point, we've got another value of t, but the velocity there is the same throughout. It's the same. But in the case of here being velocity being equal to, it means the distance, guys, here there is no change in terms of the distance, meaning to say the object, if the distance is not changing, guys, You are at point A, all right? After 5 minutes, the time has changed. After 5 minutes, you are still at point A. What does it mean? You are not moving. You are not moving. In terms distance, we're talking about from a point to another point. We're supposed to be saying, after 5 minutes, you are now at point B. After another time, you are now at point C. But you are still at point A. The time is changing, but you are still at a single point. The object is not moving, it is stationary. Here it's about the speed. You have the speed. The speed means there's a movement there. If whenever you're considering that there's a speed, there's a movement. But only that the speed is the same. It can happen, guys. You can travel, all right? You can actually drive a car, all right, at 60 kilometers per hour for 1 hour, maintaining that speed. It is possible. This is the constant velocity or constant speed. You are not changing to say from 60 to 80 from no, you are maintaining the same 60 kilometers. So you started with 60 kilometers, then after some time, someone is after 5 minutes, you're being asked, what speed are you traveling? You're still at 60 kilometers per hour. After 10 minutes, you are still at 60 kilometers per hour. It can happen. But after some time from the displacement time graph, after some time, you are still at the same point, at the same distance that you were. If you've already covered 250 meters, you are still at that point. After some time, you're still at that point. That is not moving. There's no movement there. So know the difference between velocity time graph and the displacement time graph. Acceleration to be zero, it means the object is moving at a constant what? At a constant velocity. So these are the main ones that you're going to actually have in your syllabus according to the calculations of your paper one. Then you're going to have some other interpretations that you're going to consider, which is for paper two. When you are to draw these graphs, they are going to form, in most cases, we are going to be talking about a parabola. All right, a parabola or a quadratic function, a quadratic graph, a quadratic what? A quadratic graph. So in most cases, in paper two, all right, if we are given these travel graphs, you are going to end up with a parabola there. So when you have a parabola, it means, all right, we have to consider the properties of a parabola. Here we are considering a condition when any of these are drawn, they are forming a straight line. So it can be the one that is increasing, the one that is decreasing, where this is positive gradient, negative gradient, or we can have it where it is what? Horizontal, where the gradient is what? Where the gradient is zero. These are the ones that I was referring to here. These are the ones that I was referring to from the first one, right? When it is increasing, when the gradient is constant being positive, all right? Or when the gradient is constant being what? Negative. But interpreting the two graphs, the speed, the velocity time graph and also our displacement time graph. So our ST being what? Displacement. S for what? For displacement. All right. So here we've got our other consideration for the gradient being equal to zero. This is what we have on your displacement time graph, and for your velocity time graph, that is the major case. So at the end, if you are to see these three that we have from the three straight lines, they can form something like this at the end. Let's say we join all of those ones, all the three together, where the gradient is positive, where we have the gradient being equal to zero, and when the gradient is what? Negative. So here I'm interpreting this algebraically in terms of algebra. In our algebra, we are talking about what? Gradient. From A to B, we are talking about the gradient being constant because it's what? It's a straight line. So all this part of a straight line, straight line, constant values, constant values. All right? When you've got a straight line, you're going to be considering what? Constant values. So here it is constant gradient. Yet we are talking about what? Being positive. So from O to A, we are talking about positive gradient and what? Constant. From A to B, we're talking about the gradient being constant, but that gradient is equal to what? That gradient is equal to 0. From B to C, that is a negative what? A negative gradient that is also constant, all right? And also constant. So the interpretation that you have now is taken from the two. If it is from the displacement time graph, if it is the velocity time graph, know the difference. For the displacement time graph, that gradient is simply representing what? It is simply representing velocity like we had before. And here, the gradient is simply representing what? Acceleration. So when I'm saying positive gradient and constant, I'm simply saying here positive velocity and what? Constant. Gradient equal to 0, velocity is equal to 0. Negative gradient, negative velocity and constant for a what? Displacement time graph. Opposed to the velocity time graph where this represents what? Where the gradient is what? Acceleration. It means here positive what? Acceleration and constant. Acceleration is equal to 0. Negative acceleration, which is what? A deceleration and being constant from B to C. That is the case. When we are dealing with what? Straight line. These are straight lines being what? Being combined. It can be from a curve. When you consider a parabola, like I was saying, sometimes when you are to represent these, they do not form linear, like this linear function or the linear graph. They can form a parabola, which is what actually being curved, where you consider what? The shape of a parabola. So remember, a parabola, we can have the one that is concave down, facing down like this, concave down. So what happens is that the gradient is not the same, all right? If we are to consider the other one that is concave up, all right? Concave up, facing up, open up, concave down. This one, the shape, it is what? Concave down, facing down. So if we are to consider, remember from your algebra, guys, we talked about the gradient. From those revision question papers, I talked about gradient. Say gradient is no longer the same on a parabola. That is why you see the questions when you're given a quadratic graph, the question about the gradient is asked at a certain point. They will ask you, calculate the gradient of this function at a certain point, at a certain value of x. So the gradient is calculated at what? At a certain point. At a certain point. Whenever you have to consider the gradient, it is no longer that idea that we had before where it was constant. For a straight line, this is constant from A to B, from O to A, from B to C. We're talking about constant because of what? A straight line. But for any curve, it is no longer constant. It is about how the function is presented, all right? From this one of being concave down, the values will be increasing up to the turning point, where at the turning point, it is what? Stationary, there is no movement. So the values will be increasing, going up, being what? Positive, up to a certain point where it is stationary point, which is your turning point. From there, the values are now going down, which is what? Which is negative. So if you are to consider what we had before, you can interpret not as constant, but what? Positive and increasing or decreasing. So a positive simply means the graph here is what? It's an increase. And this is what? This is a decrease, which is the same thing that is happening, but here it is now opposed to say when it is concave up, the values will start from this going down like this, which is what? Negative, a decrease, up to the turning point, which is zero. Then they start to go up, which is what? A positive, an increase. And the gradient being calculated at a certain point, it means our interpretation is going to be, all right, remember? So I'm just going to have this one in short. You're going to understand me, guys. I'm just going to have this one in short. Remember, our interpretation are from the two, the displacement time graph and our velocity time graph. From the displacement time graph, remember, we referred our gradient as what? As velocity. So if we are talking about gradient being velocity, we are saying for an increase like this, for an increase where that is an increase, where the velocity is positive, where the gradient is positive, she simply shows us that there's what? An increase. Where the gradient is negative, velocity being negative, it simply shows us that there is a what? There is a decrease. So we no longer talk about constant values. We talk about gradient velocity, all right? We talk about being, all right, positive. If it is positive, what? If it is positive velocity, positive gradient, that's what? Moving forward, which is what? An increase. We are simply talking about an increase. A negative what? A negative velocity. We simply talk about what? A decrease that is happening. The same thing on our velocity time graph. If we are to consider the velocity time graph, remember, the gradient is representing what? Acceleration. So whenever we have got that positive acceleration, when the acceleration is what is positive, that's an increase. All right. We can have a negative what? Acceleration, negative gradient, which is what? Which is a decrease. So you mentioned that in terms of being an increase or a decrease. Like I said, this part I'm going to dwell much on it when we are to consider the paper 2 part. This is mostly your paper 2 section B. When you are to interpret that, you need to understand what is happening. So this is the major case of your graphs. All right. I didn't on these straight lines, when we form straight lines, I didn't mention about a vertical line. The reason being, for a vertical line, we do not have the gradient. We cannot calculate the gradient on a vertical line because what happens is that the x values are the same. The y values can change. Let's say at this point, it is y1. It can change to another point, which is y2. But the x value remains the same throughout, meaning to say the first point will be referred to as x1, y1, and the second point is going to be x1, y2. The y values can change, but the x values are the same. That's why you see every vertical line, its equation is given as x is equal to. All right. If the line passes through the point 2, the equation is x is equal to 2. All right. In the y-x-x is because of what? The line passes through the point 0. So that's the equation. X is equal to 0. Throughout this line, x is the same. So if this is point 1, there's going to be x1, y1. Another point, because the x values are the same, just like 0, 2. This can be 0, 3. This can be 0, 4, like that. So this is the concept. So if we are to use the gradient concept, the change in y over the change in x, we're going to have y2 minus y1 over what? x1 minus x1, since the x values are the same. So the denominator definitely was going to give you a 0. Remember, k over 0 is equal to what? Infinite. You cannot find a value for that. It is undefined. Velocity is undefined. If it is acceleration, is undefined. So in this case, our gradient is what? Is undefined. That is what the denominator is equal to 0. You cannot calculate that one. You cannot calculate that. So You leave it like that. You cannot come. So meaning say you are not going to have this practically. That cannot happen. So even for our calculations, we are not going to have anything that has got what? This type of a vertical line in this case. So that is concentrate on these ones that I have illustrated before. So that is the case, just like that, just like that. And we are going to add some of the examples. So just make sure you follow the playlist, all right? I'm going to have a playlist for this introduction and other questions that we're going to consider. So make sure you follow the playlist from the first video up to the end so that you properly understand this topic. It is actually nothing. There's nothing to consider much. All right. So there's nothing to consider much on this part. So here I was explaining these two combined, the displacement time graph and the velocity time graph combined, interpreting them from what we know from the basic part of our straight lines. So guys, please do revise like all these concepts that I was explaining about a straight line, because we are considering from what? From a straight line. So if you do not know a straight line, its properties, guys, it is going to affect us in these calculations. Remember, I also referred to the other part. If you are to consider a straight line, all right, this concept I explained that the gradient that is the same throughout. It's another property that you must consider. Know these properties, all right? Know these properties, all right? So when you take values on a straight line, I mean points on a straight line, you represent a point with the x and y like this. That's a point. So you can have points on a straight line. This can be another point, this another point, this another point, this another point. So as long it is a straight line, the gradient is the same throughout. We've got what? Same gradient throughout. So using any points which lie on this line. So if we've got the point x1, y1, and another point here x2, y2, and another point x3, y3, like that. These points, if we use these 2 points to calculate the gradient, we are going to obtain the same answer as someone who used these 2 points to obtain the same gradient. We are going to have the same answer as someone who used these 2 points to calculate the gradient. It is the same throughout. It is the same throughout. So this can be used in other calculations. Now, let us consider that we have got a velocity time graph. This is your velocity and this is your time. We have got something like this. So it follows that in this case, if we said the gradient represents acceleration, remember the gradient is for the what? For the acceleration. It means acceleration is the same throughout. Constant acceleration. So if I calculate acceleration using these 2 points, I'm going to have the same answer with acceleration using these 2 points like that. Just like that. And interpreting these to say these are points, x versus y. X in the horizontal, y in the what? Vertical. So these points, you take the horizontal, it's t versus what? The velocity in the y. T versus velocity. So you take the time. Let's say this is 0, this is 20, this is 2, and here it's 10 like that. So the corresponding value here is what? Is 10. The way that you take your points, the x value representing your time, the y value representing what? The velocity. So this point here, it will be 0, 20. The x value is 0, the y value is what? Is 20. T versus v. This point, our t is what? T versus v. Our t is 2 versus the velocity. The velocity corresponding is what? Is 10. That's how you take your points from what? A velocity time graph. that X versus Y, this one, is represented from a velocity time graph. It will be what? T versus what? V versus velocity. Meaning to say, if we were to consider it from what? The displacement time graph, any point is going to be T versus what? The distance of the displacement, T versus S. That is the condition of X versus Y. So X for time, Y represents what? The displacement or the distance. So do revise as many questions as you can with this information. Use it to answer the questions. Like I said, we're going to have examples and also follow the question papers. Just follow the playlist so that you'll be able to understand everything according to your syllabus. But for now, that is it till we meet again.